we'll start with very simple examples. These are activities and the predecessor is given. These are activities, these are not nodes, these are branches, activity. So A, B, C, D, E, F, G and predecessor is this. So we have to make network diagram, very simple. So let's start here. Let's say this is our first node and the activities, see, B can only be done when A is completed. Predecessor is A. Clear? B activity will be there when A has already been done. This means A, we have to go like this. From this to this will be our activity A. Okay. Then, when A has been done, A is completed, then we can go for B. So, second will be B. So, from here to here, B. Okay. B. Then C and D are two activities. These two activities start when B has already completed. So at this we'll have two activities. See, like this. So let this be C and this be D. Okay. Now we have activity E after C. So this is C. So after C we'll have activity. After C we have E. So this will be E. Okay. And after D we have F. So this line will be F. Let this be, this is 4, 5. So this will be 6 and 7. We cannot repeat the numbering. So 4, 5, 6, 7. This is what? This is F. After D we have F. And we'll have activity G after E and F. So after this and this has been done, we'll get activity G. So there are two possibilities. See, try to understand this. G is an activity which is after E and F. That is this and this. After this had been done. So we can have several possibilities of making diagram. We can have one node here. And then from there we'll have the last node and this will be G. Okay, this will be G and we'll have dummy activity from here and here. But that is not correct way to express. Second way is since they come to the same point, we can have one point only for E and F. E and F will make one point. So this will be like this, this will be like this. This is E, this is F. I'm using blue, so let me use blue, E and F. So 4, 5, then this will be 6. And after that, we'll have G. So let this be C. So we'll have G. This is the most simple way. But what we do when we have such activities, what you should do is, I'm just suggesting you, because later on when you will be solving problems, you will understand the need. This is 100% correct. But better converging these into one node, the better way is that you do like this. See, it was like this. Okay. So 4, 5, this is 6. And this was like this, 7. And these two were E and F. What you should do, G make like this, and this is G, and put a dummy connection, a dummy branch to this. This is a better way to express this activity table as a network model. Why? You'll understand later on. It will be very useful when you will be putting forward pass and backward pass timings. Then putting this dummy activity will be very useful. So the solution of this is this. Okay. Let's say second question, just a little bit ahead of the first one. These are activities, these are predecessors, and we have duration in weeks written. How to represent this? I'm doing this. You'll have a recap of network diagram, network modeling, and you'll understand how to write duration. Let's do step by step so that everything is very clear. Now, activity A, and when A ends, then only B starts. It's clear. When A is completed, then B will start. So that is a straight line. So this will be like this. This is 1, So this will be like this. This is A. Okay, and the duration of A is 3 weeks. So either you can write like this, or the better way is, as used in book, you can write A and this is 3. So this will denote the activity, this will denote the time taken by each activity. Then after A is complete, see, you have B and you have C both after A is complete. So after A is complete, you have two activities. One is here and one is like this. So let this be 3, this be 4. So this will be, this is B and this is C. Duration for B is 5, for C is 7 weeks. Okay, you should always follow protocol. If you are writing the activity above the line, use it throughout so that it is very clear. See, so B and C we are done with. Then D is done when B ends. So D starts when B ends. Obviously it will be from here. This is D and the duration is 10 weeks. Then is E. E is when C ends. So C ends here is your, okay, so this is E. This takes 5 weeks. Okay, and then you have finally F, which is after D and E. So as I told you in last example, what you can do, let's just put a dummy activity here, and then from here we'll have our last point, that is D and E. Sorry, not D and D, this is F. D and D is complete, so you have F, which takes 4 weeks. Okay, this is the best way to present it. Now let's find the minimum time required to complete this project and find what is the critical path. See, we have two ways to go. First is this one, A, B, D, F. This is the first way. So first way is A, B, D, F. What will be the time here? 3 plus 5 plus 10 plus 4. This comes to 8 plus 10, 18 plus 4. So 22 weeks. So if we go by this way, this is 24 weeks. Second is A, C, E. This is dummy activity. So then F. So A is 3, C is 7, E is 5. The dummy activity has no time and resource. It does not take any time or resources. So then F plus 4. So this is 7, 3, 10, 15, 15 and 4, 19. Now you know the path which has the longest, which takes longest time duration is the critical path. That is, it will take 22 weeks, minimum 22 weeks to complete this project. So our critical path is, I'm just giving bold line to it. So our critical path is this one. And since this is the critical path, the critical activities are A, B, D and F. Okay, clear? And what are critical activities? These things we have discussed. So these are critical activities. A, B, D and F are critical activities. They cannot be delayed. Their start and end cannot be delayed. Okay. Let's say this question. This is a network model. We have so many 10 nodes and we have these activities A, B, C, D, E, F. All duration in weeks is given. Okay. What we'll do, we'll try to make table. From this diagram, we'll try to make table first, and then we'll find critical path and critical activities. Okay. So reverse. We'll do reverse engineering here. You see A, B, C, D, E, F, G, H, I, J, K, L. We have activities up to L. So let's write A, B, C, D, E, F, G, H, I, J, K, L. So we have written the activities. We have these activities. See, after A has completed, then only we have D. So D requires A as predecessor. Okay. Then see B. We have B. After B, E starts. So E requires B as predecessor. Then F requires C as predecessor. Okay. But ABC don't have any predecessor, so just blank. Then what about G? G is here. G starts after D. See, D has completed, then G starts. So we'll write here D. Then we'll have H. H starts after E. So H will start after E. Let's see I. I will also start after E. So I will also start after E. Then we have J. J will start after F. So J will start after F. K. Where is K? K is here. See, K is here. So K starts after G and H. So K after G and H. And L after I and J. So I and J. So this is our activity. Then just write this 8, 10, 7. 8, 10, 7. Then D 20. E 16. Then we have F 25. G 8. H 11. Then you have I 14. J is 10. It requires 10 weeks. K 6 and L 5. So 6, 5. So this is, we have done reverse engineering. If this table was given, we would have constructed this diagram. Okay. Now let's find out the critical path. Later on, we'll be using forward pass and backward pass to find out the critical path. But in the start, at very simple stage, let's see what are the different paths. First path will be this. See, first path will be, this is our first path, ADG, see, ADG, then K. This is first part. It will require 8 plus 20, 28, plus 8, 36, plus 6, 36 plus 6 is 42. So it will require 42 weeks. Second path is this one, BEHK, BEHK. It will require 10, 16, 26, 11, 37, 6, 43. So this will require 43 weeks. Third one, we have this path. So CFJL, this will require 7, 25, that is 32, 42, 47. So this will require 47 weeks. Then we have one more path. See there, BEIL, 10 plus 16, 26, plus 14, 26 plus 14 will be 40, 40 plus 5, that is 45. Do we have any other way? No. So these are the 4 different paths available to reach from start to end, and the longest path is this one, 47, CFJL, that is this one, CFJL. So this is our critical path. This is our critical path. And what are the critical activities? C, F, J and L. Okay. Let's see another problem. Here, instead of writing A, B, C, D, we have written activity as 1, 2, 1, 3, 1, 4. This is pretty easier. But just solving this so that you are very comfortable with this type of notation also. It says 1, 2, 1, 3, 1, 4. So we have node here 1, 1 to 2, 1 to 3, 1 to 4. This is clear. Then we have 2 to 5, then 3 to 6. See, 2 to 5, 3 to 6, 2 to 5, 3 to 6, then 3 to 7. 3 to 7 also we have 3 to 7. Then 4 to 7. We have a link here also, 4 to 7. Then 5 to 8. Let's say this is 8. 5 to 8. Then 6 to 8. Then we have 9. 9. 8 to 9. See, 7 to 9 and 8 to 9. This is the relation. So this is what we require. Now let's put the time here. So it will be 5, 1 to 2, 5, 1 to 3, 6, 1 to 4, 3, 2 to 5, 5, 3 to 6, 7, 3 to 7, 10, 4 to 7, 4, 5 to 8, 2, 6 to 8, 5, 7 to 9, 6, and 8 to 9, 4. So this is our network. Okay, from this table we have constructed the diagram. Now let's see what are the paths. The first path will be 1, 2, 5, 8, 9. 1, 2, 5, 8, 9. This one. Okay, so it is 5 plus 5, 10, 12, 4, 16. The second path will be this 1, 3, 1, 3, 6, 8, 9. So this will be 6 plus 7, 13, plus 5, 18, plus 4, 22. Then we have third one, 1, 3, 7, 9. 1, 3, 7, 9. So this will be 6, 1, 3, 7. So this 6 plus 10, 16, 6, 22. So this is 22. Then fourth path will be this. So 1, 4, 7, 9. 1, 4, 7, 9. This will be 3, 4, 7, 7 and 6, 13. Do we have any other path? This done, this done, this done, this done. So we have these four paths, and the longest one we have two, this and this. Both take 22. So either we can take 1, 3, 6, 8, 9, that is 1, 3, 6, 8 and 9. Either our critical path will be this or will be this 1, 3, 7, 1, 3, 7. No, not this one. 1, 3, 7 and 1, 3, 7, 9. This one, not this one. This 1, 3, 7, 9. So these two paths are critical, and any delay in these activities will affect the total duration of the project. Okay. Let's see an example. We have the activities given, we have the predecessors, duration is given. We have to find total float, free float and slack. I have told you what is total float and free float. We'll calculate it now, and after doing that I'll explain to you what slack is, and then we'll calculate slack. Okay, so let's start. The first part is to find the network diagram. So let's start with this. Activities are, see, A, and then after A has been completed we have 4 activities. So let's start with, here we start with A. Okay, A is 12. Then we have 4 activities, B, C, D, E. Okay, B, C, D, E. See, B, C, D, E. So let's do one thing. Should we go by B, C, D, E or some else way? See, E is after A, F is after B, G is after C. So let's start. B, C, if there will be any issue we'll change it, D, and then E. Okay, then we have F after B. So this is F after B. Then you have G after C, G after C. Then H after D and F. D and F. Where is F? Okay, this was F. F was after B, so this was F. And we have H after D and F, that is this and this. So we'll have a crisscross. So what we should do is we'll change it. We'll make this as this one and this as D. This is D. So after D we had nothing. Okay, so let it be like this, 4, 5, 6, 7, 8. This is D, and after D we have, this was our D or C, it was D and F. So this is C. Okay, this is C, and we had G after C, so this is G. Okay, I changed it because otherwise there would have been a crisscross. That is not desirable. Okay, now we have H after D and F. D and F, and after that we have H. So one thing we can do, here we have H. So either we can put a dummy activity here, or we can take D directly to this point, this event, that is 7. So this is D. So after D and F we have H. See, H is after D and F. Then we have I after E and G. E and G. Now again you can see this and this can be one event. 6 and 8 can be one event. So just replace this by, this is your E, and after E and G you have I. Okay, your activity is I. Okay, let it be I. Now H and I, see, after H and I you have J. So H and I after J, that is, there is one point only. So H and I will come to one event. See, this and this. This is your H, this is your I. And after this we have J. Okay, so this is a neat figure. We'll have to renumber it. 1, 2, 3. Let's write it as 4. Then this as 5. So this is 5, this is 6, this is 7, this is 8. Okay, this is J. And A is this, B is 7. B is 7, C takes 11 weeks, D takes 8 weeks, E takes 6, G takes, we have F, so F takes 10 weeks. Then we have G, G is here, G takes 9 weeks. Then we have H, H takes 14 weeks, I takes 13 weeks, and J takes 16 weeks. So now we have completed our network diagram. So our network model is complete. Now we'll see what is total float, free float, slack, etc. No, we just forgot to take the critical path. Which is the critical path? Let's see. Critical path will be, see, if we go by this path, it will be 12 plus 7, or what we should do, since we have to calculate total float and free float, we'll start with this point. So I'm taking another color. I told you we start from 0, and for forward pass, first of all we are taking the forward pass. We use rectangle. So it starts at 0. Obviously this will be at 12 weeks. Then come to this point. This point will reach 12 plus 11, that is 12 plus 11, 23. Then this point we have two ways to reach here. First is 23 plus 9, that is 32, and from here it is 12 and 6, that is 18. Whichever is greater, that we use in forward pass. So it is 23 and 9, 32. Okay. Now 32 and 13, it will be 45. But let's see, here also we have to come in. Let's see, 45 is greater, or we are through this way it is greater. Now this is at 12. So 12 and 7, 19. This point, see, 19 and 10, it will be 29. And 12 and 8, it will be 20. So we'll use 29, whichever is greater. Okay. Now 29 and 14 is 43. But here 32 and 30 is 45. So we'll use 45. And 45 and 16, it is 45 and 16 will be 61. So your job will be completed in 61 days. The project, by critical path method, we are able to understand that it will take 61 weeks to complete the project. Which will be the critical path? Obviously, this is the critical path. How? See, this will be A, then C. I'm writing A, C, A, C, 12 and 11, 23, then 9, 32, that is, this is G. So A, C, G, then I, and then J. So this is our critical path, and we take 61 weeks to reach there. Okay, this is clear. Now, I had told you in my last session, I had told you how to calculate total float and free float. Let's see. First of all, let's calculate the time using backward pass. This will be 61 only. Okay, this will be 45 only. Along the critical path, both forward pass and backward pass, the values are same. And our path is, which is our path? This is our critical path, this. So along this, it will be same. See, 45 minus the 13 is 32, then 32 minus 9 is 23, then 23 minus 11 is 12, and then finally 0. So we have calculated backward pass for this. Then let's find for which one? This one. So this is 45 minus 14. 45 minus 14 is 31. So this is 31. 31 minus 10, this is 21. But this is 12, that we know. So we have calculated the values at each event by forward pass and backward pass. We know how to find total float. Total float is in the reverse, in the backward pass. What we do? We take the difference of the backward pass values and minus the value of the activity. See how. And this is for, you should remember that this is for non-critical activities only. For critical activities, it will be 0. How? See, this is the critical activity. So 61 minus 45 will be 16, 16 minus 16, 0. So you can directly, what you can do is A, C, G, I, J, you can put 0. A, C, G, I, J. So this is 0. Directly you can write it. You can calculate also B. B is where? B is here. See, this is 21 minus 12. So 21 minus 12 is 9. 9 minus 7, 2. So total float is 2. Then D. See, 31 minus 12. 31 minus 12, it is 18 and 1, 19. And 19 minus 8, 11. So this is 11. What is the meaning of this? This means that you can delay this project by 11 days. That is, you can start from here or after 11 days. Because you have a gap of 19 days. And your activity takes only 8 days. So you can start from 0th day, 1st day, 2nd day, 3rd day, 4th day up to the 11th day. Okay? Sorry, after 11th day. 11 is the maximum limit. Then we have E. Where is E? E. See, 32 and 12. So 20 minus 6 is 14. This will be 14. That is 32 is what? From backward pass, what do we get? We get 32 is the latest day of completion. So, but on 32 or on 32nd day, this has to be completed. It takes only 6 days. So, it can start on 26th day also. This is the gap. Then F is here. See, 31 minus 21 is 10. 10 minus 10, 0. So, you don't have any, you cannot delay it. Then is H is here. See, 45 minus 31 is 14. And 14 minus 14, 0. Again, it is 0. So, where do you have scope of delaying? Obviously, you cannot delay a critical activity. So, you have option to delay only non-critical activities. And the option to delay a non-critical activity is B by 2 days, D by 11 days, E by 14 days. Others you cannot delay. Okay, this we get from total float. Then we have free float. Free float is what? This value only. Forward pass minus this. So 12 minus 0, 12 minus 12, 0. So for critical activities, I told you they will be 0 everywhere. So along this path, wherever you will go, it will 23 minus 12 minus 11, 0. So A, C, G, A, C, G, A, C, G, I, J, I, J. So they will be 0. No issue. Let's calculate for B. B is here. See, this is 12, this is 19. So 19 minus 12 is 7. 19 minus 12 is 7. And you have 7 days only. So you cannot delay it. So this is 0. You cannot delay start of B. Then this one, 29 minus 19, 10. 10 minus 10, 0. F. So F is again 0. let's calculate this H14. So 29 and 45. 45 minus 29 is 16 and this is 14. So 16 minus 14 is 2. So for H it is 2. That is, you can delay start of H by 2 days. What is left? D. Where is D? D. See, 29, this is 12. So you have how many days? 29 and 12 is 17 and it is 8 only. So 9. That is, D has a free float value of 9 days. Okay. This means that you can start after 9th day so that your project is not delayed. Next we have E. E is here. See, 32 and 12. So 20, 20 minus 6, 14. This is again 14 for this also. Okay. So we have found total float, free float. Let's now understand what is slack. See, total float, that is the delay by which a critical activity can be started so that our overall completion of project is not delayed, is total float. But we are talking of activities only when we talk of total float and free float. Slack is how much can an event be delayed, not A and B, but what about 1, 2, 4, 3? How much can this be delayed? Do we have any option to delay any event? That is, if this event instead of on 23rd day, can we delay on, can we start it on 25th day? That is the meaning of slack. So it is not, it cannot be represented on the table expressing activities. We'll have to make a new table for events. Let's see, I'm now rubbing it. So for slack, what we do, we write event and we write slack. You know what is forward pass? It is the starting point of any activity. And what is backward pass? It is the latest day at which an activity must be started. For example, it's 45. So this must be at the latest be started on 45th day. This is the meaning of backward pass. For example, these are two different values. So forward pass means 29. That is, this should be started on, this is the earliest time for any activity to be started. And 31 is the latest day on which this has to be started. So what you get from this? You have a gap of 2 days. This is earliest time, this is latest time. So you have a window of 2 days for this event to be placed. That is, either it can be on 29 or 30 or 31. This is the meaning. So that is the way we write. It is up to 8. So we write 1, 2, 3, 4, 5, 6, 7 and 8. And what we do? Backward, the value of backward pass at an event minus the value of forward pass at an event. That is your slack. So obviously on the critical path, you have 1, 2, 4, 6, 7, 8. They will be, the slack will be 0. You cannot delay that event. See, 61 minus 61, 45 minus 45, this. So 1, 2, 4, 1, 2, 4, 1, 2, 4, then 6, 7, 8. You cannot have any slack. You cannot delay these events. They have to start on the day they have been decided or determined. But we have gap, we have a window for 3 and 5. Let's see 3. 3, see, 21 is the backward pass value and 19. So we 21 minus 19, 2. So here we have a window of 2 days. That is, it can be started on 19th, 20th and 21st. So you have a gap of 2 days. Then 5. Here also we have 31 minus 29. That is 2. So it is clear, slack is clear. Total float is for activity and slack is for event. And I told you how to calculate it. Okay. So we have this chart. We have to make network model of this project. We'll find total float. You know what is free float? Just I have solved this in the last example. So we'll find total float and we'll find slack. Let's start. A, the first activity is A and duration is 8. Then we have B, C, D after A. So this is B, C and then D. So this is B, C, D. B 13, 9, 12. So 13, 9, 12. 1, 2, then 3, 4, 5. So these are 3, 4, 5 events. B, C, D. Okay. Then we have E. E and F is after B. See, E and F. E and F starts after B. So what is the meaning? After B we have two activities. E and F after B. So let it be E. Let this be F. 5, so 6 and 7. Then we have G after D. This is, so we have this after, not D, we have G after this. So G is 7. It takes 7 days. Okay. Then we have H after C, F, G. C, F and G. So we'll have an activity. Okay, see very closely. C, F, G. We have H and I, two activities. C, F and G. That is to say, we don't, these events aren't separate. These are, we can add them by dummy activities. No time, no resource. Or what we can do, we can make one node. See, we can make a node here, and C will come to it, F will come to it, and even G will come to it, converge to it. So this is your G 7 days. Clear? So C, F, G, and after this we have, I'm not writing the value of node right now because it may change, let it be. Then after this event we have two events. See, after CFG we have H and I. That is, we have one activity which is like this, H, and another activity which is I. Okay. And then we have J after E and H. E and H come to, merge at start of the activity I. So this means we have this. This is not a separate node. E actually merges to this point. So E and H, and what we get? After E and H we get J. So the next activity is J. Okay. And we have another activity K, which is after I and J. See, I and J. So that is, they'll meet at one point. So this is your I goes to this node. This is J, this is I. And after Ij you have K. Okay, K takes 7 days, J takes 10 days, I takes 9 days, then H takes 12 days, G takes 7 days, and then you have F 8, E 14, and others we have written. So let's number the nodes: 1, 2, 3, 4, 5, 6, 7, 8. Okay, now our network is ready. Okay, our network is ready. Clear? Now let's calculate the values for forward pass and backward pass. Obviously this will be 0, and this will also be, backward pass also will be 0. Then this one will be 0 plus 8, that is 8. Then we have this one, 8 and 12. It comes to 12 plus 8 is 20. This point, see, 20 plus 7, 27. From here you have 8 plus 9, 17. Obviously the value will be 27. Okay, 27 here. Okay, no, we'll have to consider this one also. 3 activities are merging to this point. So this is compared to this has less value. So we have used this, but let's find this one also. This is at 8. 8 and 13 means 13 and 8. So that is 21. Then 21 and 8, it comes to 29. So this is greater. So we'll use 29. Okay, clear? Then come to this point. This is 29. So 29 and 12 is 41. 21 and 14 is 35. So 29 and 12, 41 will be the value of forward pass here. Then come to this point, 7, event 7. 29 and 9 comes to 38. 41 and 10, this comes to 51. So this we'll use 51, and then 8. So this will be 50, no, not 8, 7. See, these are the mistakes you do. 51 plus 7, we have to add the number of days taken by activity, not the value of the node. Okay, so 58, 8, sorry, again I've done. So 51 plus 7, 58. So this is the value for forward pass. Reverse, backward pass, 58. Okay, let's find out which is the critical path. See, this is the critical path. Here, then we came to this point, this was longest, then we came to this point, 41 longest, then this one, and then this one. So along this will be same. So 58, this will be 51, because 58 minus this, 58 minus 7 is 51, and 51 minus 10 is 41. So this is 41, 41 minus 12, obviously 29. So along the critical path, both values are same. So along this, 29 minus 8. So this is 21. 21 minus 13, it comes to 8. And then this is 0. Okay. So the node that would not be on the critical path, we'll have to find which node, this 5, 1. So what is its value? See, this is 29. 29 minus, what is this? 7. So 29 minus 7 is 22. We don't have any other node. So looking at it this only, we can understand that the only possible delay for any event is at this point only. This event 5, number 5 event can be delayed by 2 days. Otherwise, we don't have any gap available. So let's find out the total float. First of all, total float is found by this minus this. So total float. Free float is this, forward pass, this minus this, and total float is this minus this. So let's start with K, or start with here. So this is 0. Why? 8 minus 0 minus 8. So A is 0. And I told you all activities in the critical path have 0 values. 0 values. So A, B, F. A, B, F, H, J. H, J, H, J, K. So these are 0, we know. Let's see for C. C is 9. 29 minus 8, 21. And 21 minus 9, it is 12. 29 minus 8 is 21. 21 minus 9 is 12. So this is C. C 12. That is, you have a window of 12 days. You have, at the latest, C must be completed by 29. So you can start it on 8th day, or you can start, you have a gap of 12 days. So 8 plus 12, you can also start on 20th day. This is the meaning. Okay. Then let's say D. 22 minus 8. 22 minus 8 is 14. And 14 minus 12 is 2. So this has a gap of 2. So you can delay the activity D by 2 days. You can start it on day 9 or day 11. Then we have E. See, 41 minus 21, 20. 20 minus 14 is 6. So here you have 6 days window. You can start here or on day 7. Then G. Activity G. Where is G? Is here. So 29 minus 22 is 7. 7 minus 7 is 0. So you don't have any gap here. Then I. 51 minus 21. See, 29. 51 minus 29 is 22. 22 minus 9 is 13. Okay, 22 minus 9 is 13. So you have a window of 13 days. You can start on day 0 or you can start on day 30. Clear? So we have found total float, and you know how to find free float. This minus this minus this. So this will be 0. This, see, 20 minus 8, 12. 12 minus 12, 0. 29 minus 29 minus 2, 2. So free float will be 2. Now let's see slack. How much we can delay any event. This was for activity. Let's see. So our events are up to 8. So events 1, 2, 3, 4, 5, 6, 7, 8. I told you any event on the critical path, you cannot escape it. You cannot give any delay to it. So 1, 2, 3, 4, 6. 1, 2, 3, 4, 6, 7, 8. So the slack is 0. No price for guessing, because at any point 7, see 7, 51 minus 51, 0, 58 minus 58, 0. That is, you cannot, because it's on critical path, you cannot delay it by even a single day. Now the only event left is 5. Where is 5? 5. 22 minus 20, that is 2. You have a slack of 2 days here. You can delay this event by 2 days. This is the meaning of slack. Okay, so we have done so many examples. I think this is up to this. It must be clear to you how to see a chart. From that chart, the chart for a project, from that chart, how to make the network diagram, then how to calculate the forward pass values and backward pass values, then total float, free float, and slack. So this is clear. Up till now we have cleared this. Next session, what we'll be discussing is crashing of event. What is the meaning of crashing of event? Very just food for thought. If your project takes 58 days, okay, you are seeing this project, what if the company wants to complete it by 52nd day? Is there any possibility of completing this project by reducing the total time by 6 days? Do we have any option? We have option. That we'll see in crashing of a project in our next session.